The last bit I want to cover is possibility to generate more agents and have multiple agents generated from the same spawn point and perform autonomous actions. So currently we spawn a single agent that starts to perform its own behaviors, right? So the goal now is to spawn, let's say, 3 different agents. Luckily, it's quite simple. So the first thing we need to do is in the spawn script, we set that we want to clone 3 agents, not just 1. But if we do this, we get a quite ugly exception in here. Object reference not set to an instance of an object, and that is that there is the application does not know where these agents can be spawned. And the area where agents are actually spawned is controlled by a bounds, by convex bounds. So we have to basically draw the area in which we can spawn the agent. So let's add a new component called the convex bounds, right? And let's say we're going to create some rectangular area around it. So the convex bounds is the rectangle is going to have 4 different points. It's specified by 4 different transform positions. So the easiest way to do this now is to create an empty child at 0, 0, 0, and let's name it a position, let's bounce position 1, okay? Or just bounce position would be good. And we attach another script called convex bounce position, right? Which draws this nice little gizmo so I can see where it is. So I'm going to move it away from the spawn agent position. So I have my spawn agent position, and this is my first gizmo of the position. So I'm going to duplicate this 4 times, and I'm going to move these other bounds around it. So I'm going to move this one here, this one here, and then the last one I'm going to move around here. And the last thing I need is basically assign these positions to each of the bounce borders, right? So 1, 2, 3, and then you see there is this bounce position drawn in between these individual gizmos. So when I add the 4th one, it actually, so I did something wrong, so I just need to modify the order. So this is my 2nd and this is my 3rd, there we go. So now when I modify these positions, I can easily see that how big is the area in which the agents will be spawned at, right? Great. So now when I run this, the last bit is I need to assign which object holds the convex bounds. And since the object itself, I'm going to just assign this convex, the spawn agent to the spawn agent, since it has a convex bounds behavior on top of it, right? So when I run this, I should start getting, oh no, there is one last thing that we forgot to do, and that is we have to limit, the application here limits what is the minimum height and maximum height at which the agents can be spawned. This is there to protect so the agents, for example, are not spawned at the top of the buildings. So I will say that the minimum height is -2, right? So the height represents the y coordinate, and since my world exists at position, let's put the world actually to 0, I'm going to limit this to -2, so it's alright, so it's somewhere below, and then height, I don't know, the 10 is okay since I have no roofs. Alright, and now since all should be done, right? So I get my 3 clones, but only one of them is performing actions, right? So obviously the problem was that there is only one pot that can be interacted with. So let's change that, right? So let's change the pot. Let's duplicate it several times. So let's put the 2nd pot and duplicate it with the 3rd pot. But now I would have to go, but there is a problem now, right? So as here in the spawn pod, I was assigning which pod the agent needs to interact with. well, this is no longer applicable, right? Because there is only one pod that can be assigned to all spawns. So basically all spawns are trying to interact with a single pod. So let's remove that variable and let's use a different functionality of move to interactive object. So I go to the demo tree, the behavior tree, and in here it is there is this action perform pod pickup, and we're going to do thing that we will say, all right, so step back. So before in your, this is already me working with that. So before your configuration looked like this, right? Your configuration looked like, all right, interact with this dynamic variable pod, and then this dynamic variable pod was fed from the spawn agent's configuration. So from this variable pod was filled to this pod, right? So that was the initial configuration. Now we're going to remove this, so we won't set the target of the action. Instead, we will say what kind of action do we want to perform, and that action is pod pickup, right? Now agents will search for the closest pod pickup objects that they can interact with, right? And since only single agent can interact with a pod, each agent should be able to find their own pod. So when I run this now, all agents start interacting with their own little pod. There we go. And that's how you can easily set up multiple agents to work with objects, right? So the difference was that the agents are not given the individual targets. Instead, they are given the action which they want to perform, and then agents can basically search for the closest interactive object that performs that action. Also, you need to remember that if you want to use multiple spawn points, you need to specify the convex bounds area in which the agents can be spawned. There is one thing I forgot to tell you, is that we have removed the dynamic variable pod, right, from the perform pod pickup. So we replaced the target with the pod pickup, but that was not correct, because for example the action of pod pickup, so if I go here in the pickup action, it actually depends on the pod variable, right? So if we are picking up something, we need that pod variable to be defined, right, in our tree. So the easiest way actually to do this is to go back to the demo tree, and when we are picking up the pod, we just basically define this variable, dynamic variable, in here, right? So I say that this is a pod, right? The action takes preference over the target, right? So sorry, the target takes preference over the action, but since pod is not defined when the behavior tree executes for the first time, it will be the action that will actually perform something, right? So if I go to one of my clones, right, I can see that the pod was filled with the correct instance of that given pod. Right? So now the agent can finally attach that pod to his body. Alright. One last thing I want to show you is that currently when agents come and pick up the pods, each of them picks up their own pod, which is great, but only the first agent, who's the fastest one, can now go and fill the pod, right? And I'm getting these errors here that there are no free spots. So the easiest way to deal with this, probably would be better with different objects, is that I can just add more spots from interactions, right? So in here I have only one offset defined for my well object, right? So what I'm going to do, I'm going to add 2 more spots, right? And so all I need to do now is tell where those spots are. So I need to put it a little bit higher so I can actually see them. And then I'm going to modify probably on this coordinate, but should we put it X coordinate? Yeah. So one spot I'll put here, and then the last spot I put on the other side of the well, right? So now I have 3 different spots from which this well can be operated from. So now when I run this, I should have my pot pickers be able to go into those spots. So as you see, each of them will get their own spot from which they can operate the well, and the simulation runs as we would expect.